Okay, so let's actually solve this. I'll tell you up front, the chain rule part, really, you need to see the chain visually. You need to set up the formula. But then from there, a lot of the math is straight algebra. It's very simple basic algebra or basic Calc 1 skills. So if I do this, dw dt equals partial of w with respect to x. That's 5 plus y times the full derivative of x in terms of t, which is just a nice 2, plus the partial of w with respect to y, which would be x plus 2y, times the derivative of y with respect to t, the full derivative, which is 1. So from there, if you notice, I have dw dt, but it's in terms of it's in terms of y's and x's. Well, it doesn't really line up. Our variables aren't matching. So what I'd probably do is I would probably want to make, for example, this y, I don't want it a y, I want it a t. So let's actually plug in the t's for this. So y is t minus 4. 2 is just 2, so that stays the same. Plus, now this one's a little bit bigger. My x is 2t plus 1 plus 2 of my y's, and my y's are t minus 4's. And if I can fit it on the side here, I still have the 1. So at least these are all in terms of t now. And I would just personally simplify it a little bit. Let's see, this would be 5 minus 4 is 1. So this is going to be t plus 1 times 2 plus, let's see here, 2t plus 2t is 4t. 1 minus 8 is minus 7. And I still have the 1. At any point, you could really plug in, because the whole thing I'm asking for is what's the derivative at 1. So you could plug in here if you wanted to. And let's do that. So let's say I plug in right here. And the whole question was, what's dw dt at t equals 1? Well, in this case, I'm going to plug in 1. I get 2. I'm going to do it all red now. I think you guys can handle that. 2 times 2 plus, let's see, if I plug in 1 there, 4 minus 7 is negative 3 times 1. This equals negative 3. Now, again, to make sure you understand this, the real calculus 3 part of this is understanding this chain rule formula based off that set of the chain. The rest of it is pretty simple math, including some algebra to get your derivative at 1, which would be negative 3. Now there is another way to do this, and I want to show you it. You could, instead of saying this is a chain, we could really force it right from the beginning to say w in terms of t. So let's take a look at it this way. Same problem, just different slide. Notice again though, this guy right now is w in terms, oh, let me kind of write that a little bit better for you guys. Right now it's w is a function of x and y. But instead, let's just force it to be w is only about t. So if I did do that, I'll do it in red here, I could say w equals, instead of 5x, 5 2t plus 1 plus 2t plus 1 times t minus 4 plus t minus 4 squared. Now if you notice, finally I do have w in terms of t. Everything's about t. So if I want, I could simplify this a little bit. I have 10t plus 5 plus 2t squared minus 8t plus t minus 4 plus t squared minus 8t plus 16. Again, that line there, straight algebra, not calc right now. And if I simplify this a little bit, let's see here. I have 2t squared and a t squared, so that would be 3t squared. I have 10t minus 8t plus another little t and minus another 8t. So let's see, 10 plus 1 is 11 minus 16. That would be minus 5t. And I finally have a plus 5, a minus 4, a plus 16. That would be 21 minus 4 is plus 17. Now notice, this is a pretty nice guy right now, w in terms of t. And if I wanted to, I could take this derivative. This would be a full derivative, because realize, right now I have w, and his only connection is t. That's a horrible t. This again. W in terms of t, that's all you have. So when I take this derivative, it would be a full derivative, because there's no breaking apart of splitting it with an x and a y. So in this guy, my full derivative here would be 6t minus 5. And if I want to evaluate that at t equals 1, I would get 6 minus 5, which equals 1. If you notice, that one is the same as this one. I just can't add. My fault, guys. Let's see. 2 times 2 is 4. Minus 3. I'm an idiot. That is 1. Again, sorry about that. This is on the previous part where we did with the chain rule. Now, at first glance, both have the same amount of algebra. Both have the same amount of algebra. And the only real difference is, do you want to first force it to be w in terms of t? And that's what we did on this second route through it. And when you do that, your chain's a lot smaller. It's just a w in terms of t. Or I can do it here, but I split it in terms of w goes to an x, which goes to a t, or w goes to a y, which turns into a t. Now, some of you might be saying, I would prefer brute forcing it into w in terms of t. But what's going to happen is we're going to get more and more complicated problems, where if we can handle it as a chain, will be a lot better than if we force it like we did here. So our next example is an object is traveling an elliptical path given by the following parametric equations. At what rate is the distance between the object and the origin changing when t equals pi? So again, what I would recommend is trying to set up a chain for this problem. Now, I don't have any formula yet. I don't have any equations written down outside of the ones that were given. So let's see if we can first kind of get an idea of this by drawing a picture. So if I drew this picture here, let's see, 1, 2, 3, 4, 1, 2, 3, 4, up 2, up 2. Hopefully you're okay with this elliptical path is what would be followed by the parametric equations given by the x and the y. And notice, if I started at t equals 0, this would be t equals 0, and I'd be moving that way. And when t equals pi, which is what we're kind of caring about, I'm asking right at that point there, right as my guy, right as this guy moves around right there, I want to know how my distance is changing from the red dot back to the origin. So let's see if we can write the equation of a distance. Distance equals, the formula that you guys all know is x2 minus x1 squared plus y2 minus y1 squared. Well, one of the points is always the same. That point there is always 0, 0. Okay? So really right now my distance is the square root, I can just say x minus 0 squared plus y minus 0 squared. Or simpler yet, I have that. Now, the whole question says at what rate is the distance between the object and the origin changing? So I'm asking for dd over dt. To do that, let's set it up again with the chain rule. To do a chain rule, I highly recommend we need to draw the chain. There's D. D has components of X in it and has components of Y in it. X is about T and Y is about T. So from here, hopefully we can build the chain rule again. Now this chain rule again would be dd over dt equals, I have that piece, which is the partial of d with respect to x, times that piece, which is the full derivative of x with respect to time, plus this partial, because again it's split between the x and the y, dd over dy partials, times the last part, which is the full derivative of y with respect to t. So what we need to do is we need to find this. So I'm going to do that on the next video, and we're going to take a look at what dd dt is.